Hi everyone. Today we're going to be starting our next unit of trigonometry. And if you look under the content section, the menu on top that has the book, if you press that, it's going to take you into where I'm going to be posting all of your lessons and including the actual lesson pages, like the booklet that I would normally be giving you in class, plus your practice booklet is there too. So that's your homework booklet. So the questions that I'm going to be assigning you will come out of these two booklets. So you can print them if you want to, or if you don't want to print, what you can do is you can just copy it out and then listen to the video and fill it in along with me. That also works as well. You can try to copy it with the video, but then you might need to pause and copy and then play and then pause again to catch up and then play and do it that way as well. So try a few different ways to see what works best for you and pick whatever works. Like I said, these are just for your notes. No one else is going to see these. So do what you like best. So let's get started. So in the lesson booklet, the first lesson, 2.1 is what we're going to start with. And basically, we're going to start with right triangles. So right triangles means a triangle with 90 degrees in it. So any triangle that has 90 degrees is going to have this box. The box stands for 90 degrees. Now, you'll also notice that the corners, which we call vertices, so each one is a vertex, are given capital letters. And the sides are also given letters, but the letter that we give a side is related to the corner that is across the triangle. So for instance, vertex A across the triangle would be side length little a. Vertex B across the triangle, you have side length little b. And of course, across capital C is little c. So that's how we label triangles A, B, C, D, E, F, G, H, I. So the corners are angles and they get capital letters. And the side lengths are lowercase letters that are named after which corner was across from it. Now, also in triangles that are right triangles, we have angles. And these angles are given Greek letters. So the angle itself is a Greek letter. Now, this letter is theta. So it doesn't always have to be theta. It could be alpha, for instance, or it could be beta. These are other Greek letters, and all they mean is degrees. So the typical one you see is the theta symbol, and basically it looks like an O with a horizontal line through the center. So that's the symbol you see here. It's called theta. And that's the one we're going to use for the most part. And anytime you see a theta, it means angle. Anytime you see a capital letter, it means angle. So they're used interchangeably. So based on wherever the angle is indicated in a triangle, that will dictate which side is considered to be adjacent, which means next to, and opposite, which means across. So if you have to go across the triangle from the angle that is indicated, so across the triangle, that side is called the opposite side. The side that is next to the angle is referred to as the adjacent side. Now, there's always going to be the longest side in a right angle triangle. So if you find the 90 degrees and you look directly across the triangle from it, that side is always going to be called the hypotenuse, regardless of which corner you're looking at. This is going to be the longest side because it's across from the 90 degrees. So it's always called the hypotenuse, always. So adjacent and opposite are based on whether you're talking about this corner or whether you're talking about this corner. We never ever use the 90 degrees as our reference point. So it's either the bottom corner, in this case this is adjacent and this is opposite, or it's the upper corner. So this might be, for instance, an alpha symbol for another angle. This now side, so the one that's across the triangle from that alpha, becomes the opposite, and this guy who's next to him becomes the adjacent. So what this allows us to do now is to set up fractions or ratios. Ratios is a fancy word for fractions. And these fractions are very specific and helpful to helping us find missing angles and sides in right triangles. Now they only work in right triangles. The triangle does not have 90 degrees, then none of these formulas make any sense. And those formulas are the sine, so sine, S-I-N-E, or sin for short, sine, is the sine of a particular angle is equal to the opposite side divided by the hypotenuse. So this number divided by this number will give you the sine of this amount of degrees. So if I did that in my calculator, so you should have a scientific calculator out in front of you. Always when you're doing trig, make sure that it says D or DEG somewhere on the screen. You might need to go into your mode, or you'll see degrees on your one of your keys that you can press. But basically, you need to be in degrees mode. So if I did sine, S-I-N, 30 with my calculator, I get the number 0.5. Some calculators, you do the 30 first, then the sine. Not mine. So mine, I go sine first, then 30. And I get the decimal or the ratio 0.5. 0.5 is a half, which means sine of 30 is always equal to 1 over 2. Whatever number's on top, the bottom number is always going to be twice as big when the angle is 30 degrees. Sine 31 is a different number. Sine 32 is a different number. So they're all different depending on the angle. The bigger the angle, the bigger the sides open up. Cos, on the other hand, is adjacent divided by hypotenuse. And tan, so cos stands for cosine, tan stands for tangent. And another way to think of tangent is to think of slope. So whenever you think of tangent, think about how steep the line is. Tan is opposite over adjacent, right? Opposite, adjacent. Rise, run. Rise over run. Rise over run, opposite over adjacent is called slope. So you probably remember this from grade 10, but an easy way to remember this, the mnemonic device, is called SOHCAHTOA. So sine is equal to opposite over hypotenuse. Cosine or cos is equal to adjacent over hypotenuse. And tan is equal to opposite over adjacent. So those are your three formulas in a nutshell. And we're going to use those three formulas to find either the missing angle, the missing side on top, or the missing side on the bottom. You need to know two parts out of the three parts, and you're just solving for the missing third part. So now let's practice how do we solve for missing parts in these different ratios. So what are the different locations that x can be? So here we have x on top. 4 equals x over tan 73. So you notice that the x is on top. That's good. That means the x can stay where he is. What needs to move is the tan 73. So what we're going to do, there we go. What we're going to do is we're going to move the tan 73 over to the other side by bringing him up and multiplying by the 4. And you got to show your work in your calculator. What you're going to do is you're going to go tan 73, so find your tan button, and then 73, or 73 first, then tan. Get that decimal. Make sure you have the 3.27 number on your calculator. Don't write it down. Keep all of these numbers in your calculator. And then you just go times 4. So our answer is 13.08. It says solve for x rounding to one decimal place. So x is going to be worth 13.1. Right? 13.08. The 8 causes the 0 to round up to a 1. Again, here the x is on top. This time there's sine 38 on the bottom, so it's the sine 38 that has to come up and be multiplied by the 6 that's already sitting on the other side. So again, on your calculator, sine 38 first. Get that 0.61 number. Don't write it down. And then go times 6. So 3.69. Now again, to one decimal place, the 6 is being followed by a 9, which means the 9 becomes, the 6 becomes a 7. So 3.7. Now, when x is on the bottom, like it is here in C, the x can't stay here. We liked him when he was on the top here and on the top here, but now that he's on the bottom, he's got to move. So the only place for him to move is up over here where the cos 36 is. But cos 36 is holding this spot. So the cos 36 has to go down and be divided to remove him, to move him to the other side. So basically he's going to come and sit underneath the 20. So what happens is the x comes up, the 20 doesn't go anywhere. He stays where he was. And cos 36 now moves to the bottom. Okay, that's how you solve for a variable who's sitting in the basement. In your calculator, you go 20 first, then the divide button, and then in my case, cos 36. In some of you, it's going to be 20 divide 36 cos. Press equals. 24.7 is our answer. Now I want us to think about this number, 24.7. Remember, cos, again, is adjacent over hypotenuse. So the hypotenuse is on the bottom and the adjacent is on top. Remember, the hypotenuse is the longest side of any triangle. So let's look at what we were solving for here, the bottom number. So cos 36 is a 20 over some bottom number. The bottom number is the hypotenuse in that formula. The hypotenuse is supposed to be the biggest side. Notice how the 24.7 is bigger than the 20? Well, that should make sense. This is the adjacent, this is the hypotenuse. The hypotenuse should be bigger. So if we got an answer here that was less than 20, we should know then that we did it wrong, because we can't have a hypotenuse, which is the bottom of the fraction, as a smaller number than what's on top when we're talking about cos. Same thing here for the sine question. We're missing the bottom number, and sine, as you know, is opposite over hypotenuse. So the bottom number is the hypotenuse number. So this should be a bigger number than 44 when we're done with it. Whatever it is, it has to be bigger than 44. So how do we find it? Well, you bring up the x because we don't like them in the bottom. You kick out the sine 76 and put them underneath. The 44 doesn't move. So x moves to the other side. 44 stays. Sine 76 moves underneath. Pick up your calculator. 44 divides sine 76. Well, look at that. 45.3 is our answer. So just still bigger than 44, but just slightly. All right. I'm going to stop here, and then we're going to start in the next video with the other examples.